at the last logical connective, which is that logical connective called bi-implication or biconditional. In the previous editions, we've been able to consider connectives such as conjunction, disjunction, and also implication. And today we'll be looking at bi-implication, which is also known as biconditional. Now this is the symbol for bi-implication or biconditional. So when we say this, because it is bi, the last lesson when we were looking at implication, we said this is the symbol for implication. Now since it is now bi-implication, then we must have two arrowheads in opposite direction. And that's how we're having this. So this is the symbol for biconditional. Another name for biconditional is if and only if statement. If and only if statement. So when you hear if and only if, then we are referring to bi-implication or biconditional. And they can also call this equivalence. As far as I'm concerned, this particular logical connective appears to be the easiest to interpret because we are saying that P and Q, not necessarily directly equivalent, but we are saying that if P is true, then Q must be true. Meaning that if P exists, then Q must exist, and vice versa. And also invariably, we are saying that if P does not exist, then obviously Q does not exist too. So that's where we form the truth table. And in light of that, we can say that the only time you have a true value is when P and Q are equivalent, because another way of interpreting is equivalence. So the only time your result will be true is when P and Q appears to be equivalent. Not literally, but in terms of the statement, in terms of the way the simple statement is actually put out. Now let's look at this. For example, P stands for John speaks English fluently. Then we have statement Q as John is from England. John is from England. So if we are using biconditional as the logical connective, what this means is that if it is true that John speaks English fluently, then we can conclude that John is from England. And also, if you find any John who is from England, then you can also conclude that that particular person actually speaks English fluently. And in contrast, if John does not speak English fluently, you don't need to ask him any question further. You can conclude that John is not from England. So that's the way it operates. So bi-implication means that P being true means that Q will be true. P being false means that Q will be false. So the only time you have a true result is when both of them are equal. Now let's quickly look at the way we form the table as far as bi-implication is concerned. Now we're going to be looking at this particular question. I want to find a way of bringing together most of the concepts that we've learned in one question, because many times when you see a reasoning question, it might look so complex. So you need to understand what you are doing, or you understand the concept for you to put to the code. So let's look at this. P cup Q, P cup Q, then bi-implication P cap negation Q. Of course, we've spoken about this cup. This is disjunction. This particular one is disjunction, and this is conjunction. So, and this is bi-implication. So we're looking for a way of bringing all of those together. Of course, we know that we only have two simple statements. So this is P, Q. Then our P will be true, true, false, false. Then our Q will be true, false, true, false. You can see the way I'm filling the table seamlessly without any stress, because I understand the nitty-gritty. It is not cramming. If you cram it, you can get it confused. Now, we know that somewhere, okay, let me say this is, negation Q. Somewhere we need negation Q. negation Q. Though we've not spoken in-depthly about negation. But in this case, let me just use this to explain negation. Negation simply means the opposite, so it's quite easy. Negation Q means the opposite of Q. So when Q is true, then negation will be false. The next one will be true. The next one will be false. The next one will be true. So that's negation Q. Then we can now do P or Q. P or Q. So remember the way we interpreted P or Q when we were dealing with disjunction. You understand how we form this table. Either of them must be true for you to have a true result. So this will be true. This will be true. This will be true. Since both of them they are false, so this will be false. If you are still getting it confused, go and watch that video again. Then I want to assure you that you will be able to understand and follow accordingly. Now the next thing we do is need to find P cap negation Q. P cap negation Q. We are bringing P together with negation Q. And the logic connector we are using is conjunction. So don't forget. And when we're looking at conjunction, we said the both of them must be true in order for you to have a true result. Until you satisfy the two conditions, your result cannot be true. So for this now, true false will give us false. True true will give us true. False false will give us false. False true will give us false. Because you need to satisfy the two conditions in order for you to have a true as far as conjunction is concerned. So we can now bring it together using by implication. So we have P or Q by implication P cap negation Q. So in this case now, by implication means equivalence. So the only time your result will be true will be when they are equivalent. Otherwise, it will be false. So in this case, true false will be false, because we said if it is true that John speaks English fluently, and it is false that John is from England, then there's a fundamental problem. So that will be false. True true will be true. That means we are good. And true false will be false, because John speaks English fluently and yet he's not from England. So where is he from? Then the next one, false false. It is false that he cannot speak English fluently and he is not from England, so we don't have a problem with that. So that will be true. It will be false when you have a problem with the information. So here is our table, the way it is meant to be formed. So you can see that it's quite easy. So as far as I'm concerned, by implication appears to be the easiest of all of them. You just need to know that once you have the same results for the two things that you are considering, then you know that you don't have a problem with that and your result is going to be true. Now quickly, before we call it a wrap on logical reasoning, let me expose you to a concept that is called tautology. Whenever you form a truth table and all your truth values, when we say truth values now in logical reasoning, it doesn't really mean that we are only referring to when you have true alone, but we are saying that a logical statement is said to be tautology when all your results are true, meaning that you don't have a false. All the final results, they are true. Then we call that tautology. On the contrary, if all the results are false, then we say that it is contradiction. So tautology, simply put, tautology occurs when all the values, all the truths table values are true. So on the contrary, we also have contradiction. So if all of them they are false, then we call it contradiction. Now let me quickly use this to explain this concept of tautology. We have to show whether or not the statement is tautology. So we have negation P cap Q. Of course, we have two simples. We have P and Q. So this will be true, true, false, false. Then our Q, of course, will be true, false, true, false. Then we need to start with negation P. So let's quickly use our negation P. Negation P is the opposite of P. So this will be false, false, true, true. Then we need to get our P cup Q first before we combine them. This is or. So P or Q. So this will give us true, 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 and false. P or Q must be true for you to have a true value. So if both of them are true, it's also better for us. Now let's combine negation P, cap P cup Q. Let's do that first. So negation P, and we're using and to combine on negation P and P cup Q, negation P and P cup Q. Don't forget it's and. So the only time you have the true result is when both of them they are true. So this will be false, this will be false, this will be true because we are dealing with and this will be false. Remember we said the true statement was the true for you to have a true result. Then finally, let's now bring it together. We have negation P cap P cup Q, then implies Q. And let me also bring back to your remembrance that when we're dealing with implication, because this is implication, when we're dealing with implication, we used a statement, and the statement we used was these two simple statements. The first one, if you pass, then the second statement, I will give you 10 US dollar. I'll give you 10 US dollar. Those are the statements that we use. So now let's now apply this so that we don't get confused. Of course, this is the first statement. This particular one is the first statement. This one is the first statement. So let's now bring it together with Q. Now, this is the first one. You did not pass. You did not pass, and we are bringing together with Q now. And I felt maybe you didn't do so bad, and I gave you the monetary gift that I promised. Will you be offended? No. So that means that will be true. The next one, you did not pass, and I did not give you. Have I done anything to wrong you? The answer is no. So we have true. You passed, and I gave you. That means we're in order. True. Then the last one, you did not pass, and I did not give you. Have I done anything to wrong you? The answer is no. True. So now that all our truth values, are true, then we can say it is tautology. Therefore, negation P cap P cup Q by implication, this is actually in brackets, not by implication, and implication Q. So therefore is tautology. So you can see how easy it is to interpret all of these questions when it comes to logical reasoning. It is not cramming, it is just understanding. That will be all for now. And on this note, we'll actually be drawing the curtain on the series that we've been doing for quite a while, logical reasoning. So I want to believe that with all of the subtopics that we've dealt with, you've been able to understand the nitty-gritty of logical reasoning, and henceforth you will do justice to logical reasoning like a professional. And subsequently I will be coming up with more insightful information, more insightful tutorials that is self-explanatory, just like this one. So please do well to give back to this channel by liking this video, subscribing to this channel, and also hitting the notification bell so that you get notified as soon as we upload very useful and insightful information, just as this series that you've just watch. And if you have not seen those other video, I'll also drop a link, put them together, in the description box below so that you can get to watch them. I want to assure you that it will blow your mind with the kind of prowess and expertise that all of those videos were dished out. I want to assure you that you stand to gain a lot of things. Thank you very much for staying put on this channel, and I'll see you in the next tutorial.